Perfect. Hello, everybody. Welcome to the live stream. My name is Rick. I'm a customer engineer here at GCP. And what we're going to be talking about today is everything your cloud provider wishes you would do from a security point of view in the cloud to make your life and our life easier going forward. So we're framing that in the context of Google Kubernetes engine security best practices. So basic outline of what we're going to be talking about today at the high level, and feel free to ask questions throughout the stream. We're happy to dive in and out and go deeper. We're going to have a fireside chat at the end of it, but we're going to focus in on the control plane access, private versus public clusters, what's the right one for you, node service accounts, the often overlooked Achilles heel in a lot of Kubernetes clusters, GKE sandbox, and why less is more, and then other factors to consider, including a bit of a sneak peek into one or two things we've got coming down the pipeline from Kubernetes. But first, who are you people? Who are we? So what I want to do, so I'm Rick Greaves, the customer engineer. On the line as well, we have Chris Johnson, another customer engineer.
Pleasure to meet you.
We have Santos as well on the line as well.
Hey, everyone.
Thank you. And Shreya, who helped contribute and work on this deck as well. Unfortunately, due to circumstances beyond our control, she's traveling to Hawaii right now, and she's not able to make this presentation here, but hopefully she's listening in, and I hope she's having a good flight and not too much turbulence while we're all stuck in the Bay Area, and she's traveling the world. So, starting off pretty quick. Are the Kubernetes engines default right for you? One of the things we often commonly see when a lot of customers come talk to us is people starting out in Kubernetes, or even people who've been doing it for a while, assume that everything is just going to be the best and most optimal solution out of the box. One of my favorite jokes I like to say is, for a company full of software engineers, the only opinion our engineers could come to is try not to be opinionated. So a lot of what we have and the way we've built and structured this out, it's the most usable and accessible, but gives you the flexibility to go through and tune it into what makes sense for your workloads and what you're doing specifically. So the defaults out there are basically a very low level foundation on which you to build out specifically what makes sense and what is right for your workloads and what you're looking to accomplish out of Kubernetes. So some of the main areas of focus we're going to be touching on, like I mentioned earlier today, the low hanging fruit and the easiest steps to making sure your cluster is more secure off the bat, pretty much before you finish deploying the application. So the first point is control plane API endpoint access. Then we're going to be talking about private versus public nodes. So in this use case here, the control plane is often managed by GCP or your cloud provider, and that's an environment which you don't have access to. You just have the end API point access, and you've just got to rely on your cloud provider to make sure data is encrypted, data is backed up, data is safe, and that no bad actors are going through and doing what needs to be inside there. However, the nodes do exist inside your project. You're reliant on your security policies and firewall rules. They're understandable based upon the way in which you work in the rest of your GCP environment, what can talk to them, what can't talk to them. So understanding what security profile and posture you want to make for these nodes is a very critical aspect into what your Kubernetes security story is going to look like. The next step as well is my node service accounts inside there. So what are my nodes able to do by default? And then what we're going to be leaning into is, what my nodes can do by default means that all my pods running inside there can do by default as well. And 99% of the time, that's far too much access and security. So how do we go down and basically lean towards a path of least privileges? So my pod can only do A. If it just needs to do A, it can't do B, C, and D. And then what we're going to finally talk about is node metadata as well. So this touches on the idea that if somehow I've got a deployment of a pod or a container inside my node, what can it access and read about my environment, which I don't want it to know what it can do. And I want to limit what kind of pods can be deployed inside there. And typically you can see this through like admission controls and stuff like this, but we have a lot of solutions baked off which make that very easy and almost like a click deploy in order to accomplish that goal. So now we're going to move into private versus public clusters. So one of the things not many people know, particularly when it comes to GKE, is master access by default is open to the public. So your master nodes, those API endpoints which you use with kubectl or whatever tool you want to use to control that, is open globally by default. GCP does a very good job of filtering those down and protecting you against DDoS, protecting you against malicious attacks. All their authentication by default, unless you specifically said it, isn't old username password. There's a TLS certificate which is required for client authentication inside there. We integrate with IAM permission controls and services like that inside there, but a lot of people don't like the idea that my master nodes can be accessed globally, and we want to go through and limit exactly where those come through. So I might want a pipeline where only my main office or my CI/CD tools and their IPs are the only service which can talk to my Kubernetes Masternode API endpoints. At the same time, do I want private IPs for my nodes? So do my nodes really need a public IP address? So all traffic's gone through and I'm relying on firewall rules to be able to filter who and what can talk specifically to my nodes. If I have a private node, these nodes can exist with just a private IP. They can still access the internet via something like a NAT gateway box on the edge of the network. Or even if I don't want to have that, I can have a load balancer or some other ingress configured, which can take pod-specific traffic and route that out. So my nodes themselves don't have internet access. My pods don't have access to the internet, but they're still able to serve traffic out to the internet as I go. There's implications there around patching, updating, security profiling, stuff like that. But this can often be a very good, safe and secure story. We often see this in PCI requirements or medical records, or even people running ML workloads, where there's just real no need for these to be public facing at any aspect. So we're going to run these in private clusters. And this leads into the idea of isolated workloads as well. So multi-tenancy is a very strong concept, which we're leaning into in GKE, and we're seeing more and more traction with in the Kubernetes marketplace out there as a whole, the Kubernetes community, sorry. So namespace enforcement and higher security policies and tools, which this names escape me right now, apologies. The idea being that I can have one control plane and multiple node pools, and those node pools very tight security stories where they can't talk to other namespaces or other node pools or even other pods and services inside there. And I can go through and have a very safe, secure way. So a lot of the SaaS solutions which we're seeing being deployed out there by companies who serve everything from databases to business insight tools are leaning into this isolated workload approach in a shared cluster environment. One thing GCP does, which other cloud providers do, and you could potentially do on-prem as well, is the peered networks. So if I have a private cluster in one project and I have another project which needs to access data inside there, rather than create any public endpoints or rather than create any VPN tunnels between the two, we have the option for peered networks where we can basically butt two VPCs up against each other, poke very specific holes through to say this network can talk to this network over these ports, and it can be one-way or it can be two-way traffic, and have that isolation there. So once again, this goes back to the idea where we see this in like PCI requirements or health records or certain BI tools or financial records will live inside the network, and these nodes are not accessible in any shape or form outside the GCP project or cloud environment in which they're running. So overall, when deciding whether to use private or public, it doesn't have to be a private cluster cannot access the internet, but there is ways to do it, like I mentioned with NAT gateways and service ingress points like load balancers and stuff like that. But there is the ability here to make a private cluster where they can't access the internet if that's a security requirement, which I need. A lot of people don't know this is an option or don't understand what this is. So the hope of this slide here and what we're talking about here is I can have a very private Kubernetes cluster, which is only able to serve the security purposes which it needs and does not have to be open by default. An interesting thing about master access as well, because this was one of the early stopping blocks, is in the past we could lock down a private network, the private cluster with master access for access only inside the same region in which it was deployed. So nothing publicly could even access my master API server. Only services or a jump box or bastion host box inside that same VPC in that region can do it. We now have the option as well to have a global load balancer in front of that internally. So I could have multiple private GKE clusters all around my GCP projects in multiple regions and be able to control them centrally from inside my GCP project. Or if I don't want that and I want regional control, I can go through and do this. Overall, the net concept here, which I'm trying to hammer through, is the idea that private clusters, you can get them as ranging from private to public clusters. We have a security story to basically fit along the way. So take time to understand, what am I looking to accomplish out of this Kubernetes clusters? What workloads going on inside there? And do I really need it to be secure? The default recommendation we say is like, assume that nobody anywhere needs to access this and then argue your way up from there. And this goes into the idea of like, should I allocate a public IP address? Yes or no decision process, which goes through. Once again, reduces the attack surface, XYZ. I kind of went into that in the previous one. Now we're talking about the control plane accessibility. So like I mentioned earlier, we've removed basic authentication from inside here. So no username and password. It's got to be client-based and certificate-based access. That's basically default in there. We do have the option to override that if you do want traditional login inside there. If you don't like security or you like people mining Bitcoin in your Kubernetes cluster, feel free to go ahead and go do that. Or there might be some other use cases where that makes sense. We strongly recommend as well disabling the Kubernetes Web UI dashboard. We do that by default these days, but it is still an option and people see that out there. There's lots of tremendous tools, more safe and secure out there, everything from Prometheus to a Stackdriver or a CloudWatch, stuff like that, have that ability to build into it, and it's a lot more transparent and tied in specifically to your environment for what you're running in. The interesting aspect of this as well is the authorized networks. So this is almost like a firewall rule set for my nodes, and it's a firewall rule set for my master control plane as well. Who can access what, who can send what inside out, leak credentials and services and scope out there. Yeah, so in summary, the best practices which we have right now. Do not try to host these for any additional roles. Use Kubernetes cluster nodes, Kubernetes worker nodes, only to run Kubernetes worker actions inside there. I have seen other businesses try to SSH in and install MySQL inside there, or I've seen them try to set up a Docker repository inside there. Keep these locked down and specific. We actually have a function inside GCP where we do binary authorization, binary validation, and node checking and verification as part of the Sandbox and gvisor suite, where what we actually check is to make sure that the OS hasn't been patched or mutated in any shape or form since basically our pristine version of a node. So if someone has gone through and modified that node, it will automatically be rejected from the Kubernetes cluster. Services pods will redeploy as you would expect, and then we will automatically provision a new node while cordoning this one off to the side for review. We strongly recommend and avoid situation where you install config management tools on the node. That does not apply to daemon sets. So if you need a daemon set which needs to run through and install something, Prometheus monitoring, other performance benchmark tools or like Istio or something like that on there, that does not apply to that. What we're talking more specifically there is if I need to go through and put Chef or Puppet inside my Kubernetes node in the cloud, you're doing something wrong. Don't worry about that. Let Google worry about building the node, and you can checkbox to make sure it's safe and secure in the way which you need it to. Use the kubectl as the primary method of Kubernetes engine interaction. Once again, don't SSH into nodes and try to run pods in there manually yourself. I have dealt with customers who've tried to do that and then not understood why resource constraints are running out, why it's not performing the way they expect, or services aren't happening the way they do. kubectl is a very clean entry and exit point for data and metrics and being able to provision workloads inside there. We also lean very heavily into the container OS. It's something Google actively supports and we push in development for. I know there's use cases out there where people need something like Ubuntu or potentially custom stuff. I worked with a customer who we made custom nodes for Red Hat and CentOS because they had certain FIPS requirement. But using Container OS, we're leaning into those standards. We're going to start baking in GPU drivers. We're going to start baking in more FedRAMP compliance and stuff into that image going forward. So the idea being that stick with the OS which is designed for this. Of course, there's going to be different opinions about what's the right path forward, particularly if I care about Docker or container runtime. We're building in that flexibility to support that. So rather than bootstrap it yourself, what we recommend is lean into what we're offering out the back. And yeah, the last one is the same thing as the kubectl. Don't directly command line into my nodes. So what we've got right now is a very quick demo where I just basically want to highlight some of the things which we've been talking about right here. So if everyone can see my screen okay, I've got one of those big fancy 4K monitors to compensate for staring at a screen all day long. So what we're going to have a quick look at here is we've got basically two clusters up and running right now. One is literally default. If I just run a Kubernetes build cluster for me, this is what's going to run out and deploy for me right now. So a lot of the defaults inside here, a lot of the things which we didn't talk about, which we talked about, which aren't particularly solid inside here. So right now, master authorized network is disabled, so anyone anywhere can try to ping my IP address and run Kubernetes endpoints against that there. So 35, any eagle-eyed viewers out there want to go try something, please feel free. We're not doing any shielded nodes. We're not doing any workload identity. We've got node auto provisioning. And we've basically got a bunch of nodes which are running in a public IP space, and all these can go straight out to the world and do exactly what they need to do inside there. So if I go to compute engine, where's compute gone? I can actually SSH directly into one of these nodes. That's just popping up here. Oh, you guys can't see this. Apologies, I'll work out that out later. Well, we can go in and run a bunch of commands, and I can look at the firewall rules. But if we look at one of these instances here, it's got a very public IP address where people can go through and see what's going to be happening on inside there. And there's going to be some traffic bouncing off the side of this as well at the same time. So what we're talking about here, and why a lot of this isn't bad, a lot of this isn't great, is there's the security permissions in the profile. It's just a very public cluster. Everything from my nodes to my command API space is just wide open to the world. Everyone can go through and do what they need to do. I'm running a slightly older version. There is upgrades available out there. I should definitely patch that because there's some CVE security concerns which I need to go through and patch. What's interesting as well is we've got a pod IP range. So these pods actually exist and can communicate to resources inside my GCP project. So one of the things which isn't enabled in this one, so apologies, I'm just going to skip right over that, move on. Now, if we pivot slightly to a more secure cluster here, which is just running through the basic steps, which I would recommend, what we're looking for here is we've got a master authorized network, so all of our IP addresses are able to do it. We've disabled global access across the board, so no one, you can't manage this internally outside the region which it's in. These are the only networks which we support, and you can augment as many of these as you want to go ahead and do. What we have configured as well is a node pool, 2 node pools in this use case here, both with private IP addresses. So none of these nodes are public facing at all. There is pods and stuff being running inside here, which is only available to be accessed right now via the ingress, which we configured, and the firewall rules around that. We have configured a custom service account, which is something I'll lean into in the next step. There's a whole bunch of other features we've enabled with the gvisor, the secure boot, the integrity monitor. So leaning into these a little bit now. So secure boot validates to make sure the OS is configured the way the OS is installed and configured the way which is required by the Kubernetes cluster. Gvisor is gvisor. What that does is basically limit what kind of pods we can deploy inside there at a very, very high simplified level. What we're looking at doing is like limiting what my pods have access to on the master node when NAS is running through and doing it. And yeah, so the net, what I'm saying is I can still interface and react, and these clusters still perform in a very similar way. Like there's no extra features I'm missing from a default private cluster versus a public cluster. I'm able to go through and do it. It's just an increased security story for me to go through and do what I need to do. And I think we've got a question, so I'm just going to pause for a second.
Yes, we do. We actually have 2, and that kind of goes back a little bit.
Okay.
What are your thoughts about container D? Together. I know that on one cluster of a friend of mine, just switched, worked rather well. It was seamless. But what do you say? I mean, is it a good thing to switch? Why would you want to switch to container D? That's the first one.
I like container D. It's something we're leaning into more heavily here. A lot of my experience growing up was with Docker. I say growing up, but it's more of a relevant field. I just feel that there's more independence around this, and there's more flexibility, and it's more of an open standard, which has been supported, and there's a lot of benefit. There's some drawbacks potentially with that. We do support Windows workloads inside GCP, and as part of that, that does require the container D runtime inside there to go through and do what needs to be in there. I see that there's a lot more focus on the security emphasis on container D, I would say, than what I've seen with Docker. I think Docker's approach from a usability standpoint, and they're now pivoting more into their Kubernetes space, and they're moving away from Docker Swarm and all that. But container D would be what I would say would be my default platform going forward on a lot of solutions where possible.
This may date me a little bit, but with CoreOS, they were trying to do something with Rocket, I think, originally. Mm-hmm. They kind of went away from it. Do you feel like the intent of where that was is kind of where you think Container D will go as far as
Yes. I do think it's a spiritual success. Like there was a lot of hopes and dreams inside there. I think that the container, the interest in container, the development effort in the container space has grown a lot than it was there. So there's a lot more engineering effort and focus in there. It's a common thing for us these days to get security bulletins and updates internally about security concerns and how we're patching and working on that. And a lot of the emphasis and a lot of these are coming from the Container D runtime space. Like we're patching, we're working, we find these isolation issues going forward. I would definitely lean more into Container D than that. And it leans into my approach as well. So I have a little bit of a sandbox I can jump on and talk about. Like I love open source. Anything which is more open source is going to make me happier. And although Docker is pretty open for what it is, it's still owned by a company, and I just prefer Container D.
Perfect. We have one more, at least at this point. The question is, if your cluster doesn't have public IPs, on the nodes themselves, how much is the configuration to actually get the netting going? And what kind of restrictions does that give you if you need access to the internet and all that type of thing?
Sure. So very simply in GCP specifically, we default auto assign routes and stuff like that to you. So if I went to GCP console, which I'm showing now, I can literally just create a NAT box when this page pops up, and there's already one configured inside here. And now all my nodes have NAT access based on whatever IP address this is inside here. So the advantage I see this is if I want to patch my nodes, or if I need to run my containers need to reach out and do this, that's what I'm going to do. But I don't want to manually patch my nodes. I would honestly say I'm just going to rely on Kubernetes, and I'm just going to tell GKE to go through and upgrade my nodes, and they're going to provision the latest patched safe version for me. It doesn't need a public internet connection at all. And my containers at the same time, I'm going to lean into the idea that I want my containers to run fully executable, so they don't need to have any external dependency to go download stuff or do what they need to do inside there. If my containers do need to reach out and pull down files, say from a Git repo, or if they need to go through and reference stuff, then using the NAT box would be helpful. And then I can set up rules either at the Kubernetes level for what pods can go through network policies, or I can set up firewall rules inside my GCP environment to do it. I would say lean towards the Kubernetes rules, because that's going to be more cloud agnostic and it's going to help you run where you want to go through. So you're going to have the same security story. If I make security rules inside GCP or firewall rules, that's very GCP specific. But at the end of the day, a lot of the private clusters just don't have any internet access at all. Everything comes down the way it is. They can still access products and services inside GCP. And one of the things we want to touch upon is like the service account. So for example, they can pull down images from the Google Private Registry Info, GCR, our container repo, via private access without needing public internet access. So they can pull down images securely internally. We can also do like cache lookups for images in the container registry as well for common Docker Hub images. So like Nginx, stuff like this as well. So if my image container is hosted inside GCP, I won't need internet access at all. If it's not, that is a consideration, is I might need to set up a rule where these nodes have internet access to pull down that container registry. But at the end of the day, if I'm having a fully private secure node with no internet access at all, I would lean into that heavily.
Okay. Thank you. That's all for right now.
Perfect. Okay, I'm going to jump back over here. So yeah, we're going to dive into that. I keep teasing stuff ahead because all the fun stuff is a bit later in the slide deck, so I just wanted to jump into that a little bit. Chris, do you have anything to add before I move on?
No, I think we can move on to the next section where we're going to talk about hardening service accounts a little bit.
Perfect. Hardening service accounts.
Thank you, Rick. Yeah, so I wanted to just call out, as Rick was mentioning earlier, there is, by default, there's a pretty big security hole in theory, right? By the nodes themselves are given the compute engine default service account. So for those that aren't familiar with what that means, essentially it gives that service account full IAM project editor permissions. So what that will give you is ability to modify state with the service account, create and delete resources, right? So what we want to do ideally is minimize the amount of privileges that account has. So closing the gap, there's a couple ways we can do this. You can lock down the specific roles of that service account and reassign that service account to that to the node itself. And one of the ways we can do that is with workload identity, which we're going to touch on a little bit in a couple slides here. So some best practices we just want to call out. So administrator only SSH access to Kubernetes nodes. So ideally, we would lock this down so that we don't have a lot of users just popping in. Let's see. Rick, can you touch on some of the other features here? Just the kubectl exec, and why we want to lock that down.
Sure, absolutely. So the last thing you might want, so if people have got kubectl access, you don't want other potential bad actors or people inside your company jumping into pods and accessing stuff they're not supposed to be able to do. At the same time, we want to limit who can deploy what we have inside there as well. So a random developer for testing purposes, like, oh, I found this really handy all-in-one DevOps tool, which I'm just going to run this pod inside my Kubernetes cluster, and that's going to branch out and start doing a lot of whatever it shouldn't be doing inside there. And at the same time, the idea is SSH into Kubernetes nodes is we don't want people logging in, like we're saying, installing things which are not supposed to be doing inside there, reading logs, accessing data, and changing the way we go through. Changing the node shape and behavior from what we expect them to. Best case scenario, it's an innocent thing and someone's like, oh, if I just run this one command, the pod's going to work and everything's going to be great. They go out and then Kubernetes being Kubernetes, node scales down, the next one pops up and the issue pops up again. Like from the most innocent point of view, you don't want anything to be manual. You want either daemon sets to go through and do that. You want some node configuration values to go through and do that, but it should all be inside a pipeline. Worst case scenario, someone inside the organization is going in there and trying to put something in there they're not supposed to be able to do. Bouncing on to the idea of namespaces for a violation, like I mentioned before, namespaces are we've seen as more and more key and critical going forward. So how we isolate those, we expect some more tighter securities. We are working on IAM permissions inside there when we want to have a service account demo in a little bit, which has very specific GCP roles and access. And being able to tie those into deployments and being able to have different service accounts and different namespaces and who can access those service accounts is going to be quite critical in making sure that pods only have access to what they're supposed to do. And Workload Identity is the GCP tool which does that, which marries between a GCP service account in IAM and a Kubernetes service account inside there without the need of you having to ship JSON keys or PEM keys or username and passwords. It's just a merging of identity between the two platforms to keep things safe. I really like that, and I think that's very powerful.
Quick question, if I may. Someone was asking, what are your thoughts specifically in using Google Groups for RBAC? It seems to be kind of problematic now. Do you anticipate that kind of a model to be able to enable on an existing cluster?
Yes, if it's not already there, it will be soon. Like we are. There's an interesting use. There's two stories I would say about this narrative about using Google Groups inside and those sort of roles. There's certain large-scale organizations who have that requirement where they want people to be able to dip in and be able to do specific stuff. So by tying it into Google Groups, we've got the more aggregated permissions. So anyone in the security team could go in and pull the logs or something like that if we don't have a logging, or they're able to run execute, or developers are able to run certain commands and processes inside there. So there is a school of thought where we're trying to meet the business and their current business practices, and Google Groups make sense. From my own personal point of view and my own soapbox and chair, I don't like that. I think everything should be outside the cluster, and you should access control via stack driver, view whatever monitoring tool and solutions you want, and everything should be controlled and monitored from outside the cluster rather from the inside out. And who can deploy where, when, and what goes through these pipeline tools. Honestly, this goes back to the idea that we made this to try and not be too opinionated or force people to do things a certain path, but I'm not overly keen on it myself. Other people can disagree with me. That's perfectly fine. You're wrong, but you're welcome to disagree with me.
Thank you.
That's a very good question. Perfect. Bouncing on to the next slide. I'll pass that over.
Yeah, hi, this is Santosh. So let us talk about the workload identity. So basically, what is workload identity and why do we need workload identity, and what are the advantages we get if we use workload identity? So basically, for example, there are some applications which are running on GKE, on Kubernetes, and then those applications have to communicate to or contact the other Google resources something like SQL, Cloud SQL, or cloud storage, or BigQuery, or any other cloud services, maybe a machine learning model. So you want to connect to the API which is running on the Google Cloud, and your workload is running on GKE. So traditionally, there are two ways, right? One is basically you create a service account, and then you download the keys in the JSON format, and then we create a service, and then we store it as a secret, and then we map that as a volume to Kubernetes, and then the pod communicates. So using this model, when there are multiple services, multiple applications running on the cluster, it becomes really tedious to manage all the keys. And for example, there is a developer who is working on the company, and suddenly he leaves the company and he has the key with him. So that's a security breach, right? So manually managing all the security keys, and these keys are 10 years valid. They expire after 10 years. So it's a really security breach to manage all the keys, and it's tedious to manage them. So using workload identity, we do not have to manage the keys. So this is a keyless service offered by Google. And another way of traditionally accessing the Google Cloud services from GKE is using the service accounts which are created on the nodes. But this way, when a service account created on the node, which is part of the GKE cluster, the service account which is applicable for the node, so all the pods running on the nodes will get the same access. So this is not a best practices. So the workload identity is basically implemented to overcome these limitations. Basically, it's a recommended way to authenticate to Google APIs or Google resources from the GKE. Basically, it replaces the traditional models of using the service accounts for the nodes and using the keys. It's more secure. It's easily manageable, and you don't have to have the knowledge of identity management or credentials management. Everything is taken care using the workload identity. So basically, what happens is we create the Kubernetes service account, and then there's a Google service account, and we create a relation between them, and then using that, we should be able to access the Google services, cloud services, other services which are running outside GKE. Can we go to, yeah, Rick, you want to add something?
Yeah, there's a question here. How do you do signed URLs with space identity, workload identity?
No. So I'll take that, Santos.
Yeah, sure.
So what we would do in that use case there was we would create a GCP service account, which has the permission to generate signed URLs to go off and do what needs to be done. This is a Terraform example. We've got the roles like inside there. I'm making this one inside there. So that would have the role to generate signed URLs. And then what we would do is link that to the Kubernetes service account, which is what we have running inside here. And then we actually have a deployment which just uses that service account. Oh, wait, wrong one. SA deployment, where we just literally reference that like a regular service account, and then all the credentials are just baked in inside there. So inside my code, now that pod has the ability to go generate signed URLs using Python, using Java, whatever language you normally would, because it's using the permissions of that security account. In this use case here, which Santos is just about the demo, that is literally everything which is involved. You don't need to generate keys. You don't need to generate access profiles. We've made an IAM-based service account. We linked it to this Kubernetes service account, and now we're just using that regular Kubernetes service account inside here and to go do what it needs to do. And in the third demo, we actually kind of highlight differences between the two when we do that. That answers the question?
Yeah, I think so. The reply was oftentimes it'll ask for the actual JSON key.
It shouldn't do that. That would be it. So when you're generating these signed URLs, depending on the libraries which you're using, it can inherit it from the metadata inside the pod to go through and do it. There's actually a demo I have here, and there's actually a bad actor pod which I made, which we'll talk about. So this is Python. And once again, I am not a coder. Feel free to laugh at my code. I don't take it personal as I go through and do it. But there is a service discovery where I'm going through inside here. So I'm making like a storage client here, and it's automatically scoping that libraries in which goes through and does it. I actually use this to highlight how this is so easy for people to go through and do bad stuff inside your Kubernetes cluster because they don't need the JSON file. They can just inherit the metadata and the specific profile and the bad stuff we can do. So in the demo here, it lists all the GCS buckets and all the IAM service accounts and read-only, but in theory, the default compute engine lets you edit and update those at the same time as well. So it should be able to scrape that through from metadata. If not, when you see this demo as well, you can actually read that JSON value. I'll give you a little sneak peek of where that is in your access token. You can scrape from a metadata, which you can pass through and read.
Okay.
Go do what you need to do.
Thank you. We look forward to the demo.
There's a better one before that. So I'll pass this over to Santos. So tell me what I can do, mate.
Yeah, probably maybe we can explain the architecture a bit. So basically this demo, we want to show how a WordPress, how to deploy WordPress on GKE with workload identity enabled and without workload identity enabled. We already deployed because it takes a lot of time to spin up the cluster. So basically WordPress deployment, WordPress is an application written in PHP, which is like a front end. And then we have a load balancer, which is internet facing. So load balancer traffic will be redirected to the front end, and then front end will write or retrieve or read the data from the Cloud SQL, which is a managed Google service. So while connecting from Kubernetes engine from the front end WordPress to the Cloud SQL, either we can use the traditional model, which is like create a service account, download the keys in the JSON format, and then create a secret, and then map it to the pod and then access it, or we can enable the workload identity and create a Kubernetes service account and create a IAM service account in the Google, and then create a relation between them, create annotation, and then use the workload identity. So this is the demo which we already created. Maybe we can show in the next slide the YAML files, the deployment files. So basically what we did is we created a deployment. We created a service which is like an abstraction on top of all the pods, and then we created a persistent volume claim to store the data. So this explains, so basically WordPress is exposed as a load balancer because this is exposed to the world, and then we have the deployment which takes care of creating the pods using the WordPress image, and then Cloud SQL Proxy, which is like a sidecar container which is used to connect from the WordPress to the Cloud SQL and insert the data into the DB.
Yeah, Rick, if you want to swap over to the demo now, I think that would work. And I just want to let everyone know that all this is going to be available for you in our Git repo. So we've put all this and published this up in our Git repo. We'll have this available for you at the end of the presentation. Rick, you're on mute.
Yeah, maybe we can click on the one of the links and show them the WordPress. But ideally, I mean, in both the scenarios, with workload identity and without workload identity, the portal looks same, but internally how the pod is communicating to the Cloud SQL is different.
Rick, you're still on mute, my friend.
I'm good. I don't want to overtalk Santos. He's got some good content going on here. All right. So if we jump in and have a look, I mean, you saw the YAML there, which was listed before. What we're running inside here, I just want to call this out specifically, is there is a container inside of here called Cloud SQL Proxy. This is one of our recommended ways for instances inside Kubernetes to talk to Cloud SQL. The idea being that you can either run this inside the pods as is here, or as a separate service deployment. And this kind of acts as the gateway controls between my Kubernetes cluster and Cloud SQL. It can also act as like a gateway limit. So you don't know how many pods you might have at a given point in time. And each pod has a lot of connection overhead when it connects to a database. So by using Cloud SQL Proxy, you can kind of like funnel them through basically Proxy, which has one long lasting connection to get the data back. So by default, what this Cloud SQL Proxy is running is it's connecting to our internal instance over that IP. So there's no, right now it's using the default built-in node service account to be able to go through and accomplish that. There's no username or password or anything provided. It's another example of where it takes information from the environment in order to make the connection to do what needs to be done. When we switch over to our more secure cluster, What we've actually done is one of the default things we've changed inside here is the default compute engine service account, which is running on this, to one which is specifically called GKE node. And this has the bare bones minimum permissions. So this basically can put logging metrics and put stack driver performance metrics inside there. It also has very specific access, which we're highlighting against one GCP bucket. If this is inside this one, I'll just see if I put it inside there. Nope. Put it inside here so you can roughly see what we're talking about, good and bad. I am that binary in life. There you go. Variables. So these are just the roles which it's been assigned to on the node rather than compute editor. So by default, this node can't connect to Cloud SQL. It can't connect to data store, can't connect to BigQuery or anything like that. By making a specific service account with those very specific permissions, which in this use case here is just a Cloud SQL client, we now have a workload which has the permission to connect to Cloud SQL, and other workloads in there can't if they don't use a service account or make their own service account which has that permission. So the difference here is very subtle, but the understanding, the implication is that if we were to roll out WordPress again on the same node, which did not have this role attached to it, nothing would be able to connect to it. It wouldn't be able to follow. The Cloud SQL proxy would fail. Everything wouldn't happen. What is interesting, what matters about this as well, is we can actually map an IAM permission role between projects. So we could have Cloud SQL deployed in one project, connecting to a Kubernetes cluster in another, and using the service identity, we're able to bridge the gap between the two of permissions just for that one specific workload which is running inside there, and not everything which is running on the node. So workload ID, like, it's very transparent to your YAML. It's just a very plug and play, but it gives you that fine-grained control. So like I was saying earlier, when we've got those the clusters of multiple namespaces inside there, I can have a namespace and a user specific inside there roles and permissions. So one example I know is like customers upload data to a BigQuery data set, but each customer needs to upload to their own BigQuery data set. So by making these individual service accounts of this workload identity, each pod can upload their data to their relative data set to go through and do what they need to do. And they can't read and access any other customer's data set. They can only read and access what they want to do inside here. So WordPress is a great example of this on the fly. The site doesn't look great, but that's mainly because it's us and we're engineers, not coders or stylistic people, although we are in the Bay Area. I think we should all have mustaches and cups of coffee and talk about IPA beers or something special like that. But I think that covers it. Like the main gist and what we really want to hammer home is the idea that it's very easy and transparent to deploy these. And you can configure the infrastructure in one set, and you can do that dynamic, and then you can do your deployment on the other side. And all this repo is public. So we've now got a service account which anyone can go out and rip from the Git repo, but it won't work in your project unless you modify it for your project scope inside there. So there's no JSON keys, there's no variables out here, there's no, whoops, I accidentally Git committed a JSON file. I need to go delete the Git history because Google's yelling at me, Kubernetes, Amazon's yelling at me, Git is yelling at me and stuff like this as well. It's all just stored as metadata inside the project. So my barrier to risk is low. And like Santos was saying, these are short-lived keys. We rotate them for you constantly. Like we go through and do it all the time. We're linking IAM over. So this is one of the things where I don't like roles, but I do like tying together my IAM permissions inside my Kubernetes cluster and out to give me that single pane of glass interference. If this makes sense. Hey, Paul.
So just a quick question that's maybe not totally related to this area, but there was a question about multidimensional pod autoscaling. And I think we talk about WordPress and other things where you have this potential need. How does it run? When is it going to be available? It's supposed to be kind of late Q2, I think, 2020. Kind of see the status of that.
That is definitely in the works. I have played around with it myself. I'm not sure if it's alpha or beta right now. I just know it does exist, and we have got some examples of it. I think one of the bugs we're trying to work out is the end user interface. Like, how do we map this into YAML to go through and do what needs to be done? My email will be at the end of this. If the person wants to ping me directly, I'll see what they can do to see if we can get you access in the alpha or something along to that effect and see what we can do. Right now, what I would say would be the best path forward is we do support audit scaling based on custom metrics. So if we come up with a way to make an arbitrary metric which makes sense and publish it to stack driver, we can auto scale on that. So maybe it's like a calculation of like X amount of connections divided by CPU load times the day of the week times what I had for dinner, whatever makes sense, sort of thing like that, to get us a rough approximation. We can use that for now, but multi-dimensional auto scaling is interesting, if not very complicated.
Yeah. Okay. Thank you.
It's a very good question.
Yeah, you were talking about the proxy cloud SQL sidecar. And you also said maybe you could do it outside of that.
Yes.
So, this is kind of specific to that, but more of a general question in regards to that. So, if you don't have a sidecar, well, how do you figure out the scaling of those separate pods, if you will? I know if it's inside, no problem. But if you're separate like that, how do you do scaling like that?
I would use number of connections would be my metric, because if I know my ratio might be like 10 front end pods, even at worst case scenario needs one SQL connection proxy. So I'm just going to scale up and down based on that. And I'm going to be able to tell that based on potential legacy or latency. So I can either do connections if I want to clean, or if I've got time and effort, nothing better to do over the weekend, I'll see if I can track metrics of some high performance queries against that. And I'll go work out to be like, okay, if an average query length is this, I know I need another one, and it's going to auto scale out, because your MySQL connection doesn't care what SQL proxy it's using as long as it's using one. So you could even set up just round robin in front of that as well. I like the idea of doing multiple separate deployments, mainly because I want to limit the amount of open connections I have streaming to my backend database. And if I do a one-to-one mapping, and if I've got 50 pods, I've got 50 connections going straight through. If I can get away with only needing 5 and still get the same performance, I'm going to save on some backend performance as I go through what needs to be done.
So on the kind of a different way of doing it, how about like node local proxies, or maybe a proxy through daemon set, connecting like the magic port, host port?
That would actually be a very good approach. I think that would be good. You just need to think about, is that going to give me the performance and the throughput which I'm looking for? If I've got a daemon set, maybe 1 or 2, like each one running on there as I do it. But that would definitely be an approach. To be honest, I hadn't thought of that, and that actually kind of makes quite a bit of sense now I think about that more. It would definitely be something I would look into exploring. Okay. Stuff like that as well. Daemon set with labels and taints and affinities to make sure it only matches where my pod is deployed. Because while the Cloud SQL proxy can connect to multiple different Cloud SQL, and you can actually put through different, I want to connect to this database as part of my connection string, and Cloud SQL proxy route it to the relevant one. From a security profile point of view, it would make sense to really limit and lock that down a little bit, is what I would say. So I don't want my pod potentially talking to different databases. If I'm trying to be as safe as possible, I want one-to-one mapping going through and doing what I'm doing.
Thank you. I think that's it for right now.
That is a very good question. That's a very good question. A good way of thinking about that. Perfect. Santos, if I didn't steal all your thunder, anything more you would like to say?
Yeah, I think that's all.
No worries. Perfect. So this is what we're going to come down to. So some of the key decisions before this kind of plays into the next step for what we're going to be doing inside here. So what permissions are needed by environment? This is where what roles are required and what permissions are required. This is what these service accounts solves for us. We're taking away the more general, and we're getting very laser focused into what we're doing inside here. A couple of keynotes though: service accounts to all the containers inside the pod. So you need to be very targeted on that. I'm not sure where we are on service account for a specific pod inside a specific container inside a pod. My understanding is where we are right now. It's all containers running inside a pod. I don't know why I'm suddenly getting those two confused. The roles my node needs is just bare bones. Just do the absolute minimum. I just need to send logging information. I just need to send that to that. To be honest, you don't really need those. We use them for auto scaling, particularly the metrics. But if you use Prometheus or something like that, and you have your own logging mechanism, you can get rid of that. And if you have your own custom auto scaling, I think there's some ways around that. But I would still recommend leaning into the bare bones permissions, which we have highlighted in there. Definitely apply the privilege of these principles, and then enable metadata concealment on your nodes. And that's going to be leaning into where we're going next on it. So what are my pods and what can my pods see inside here? So GKE Sandbox kind of takes the gvisor, the open source thing out there, and we kind of try to take it to the next level inside there for what can we do and how can we make this easier for customers and for people running inside there to make sure that their pods aren't doing what they're not supposed to do. Once again, this is pretty workload specific, but we're trying to help you get away from having any use case or any need for where you would go through and do it. So, big believer in sandbox containers. We go through lockdown to make sure that as part of the sandbox environment, part of gvisor, we make sure that you don't share a host PID. We don't allow runners root. We don't allow it to go through and access volume mounts or mount anything running on the core node underneath. You're able to run, but everything else you're able to do. So shared volumes, permission sets inside there, which makes sense. GK Sandbox uses gvisor. Went through one with it, stuff like this. It's very easy to go through and check the box to have it enabled to make sure that it's basically a more robust and solid admission controller out the bat rather than you having to go through and write your own right now. It's still recommended to go make it and undo what you need to do, but if you just want a nice easy one off the bat, which works pretty well and is open source and out there, run ahead and go do what you need to do inside there. We've been doing this for a very long time behind the scenes. What you see in App Engine Cloud Functions, I'm sure Lambda and stuff like that, there's their own versions of it and stuff like that. VM Sandbox, each pod run its own VM. I'm not a huge fan of that. I think it can accomplish something similar of nodes and taints, but it is something interesting we've got coming down the pipe. But the whole overall idea, what we're looking to do with a sandbox container is really isolate the containers from each other on the node and what's happening inside there. So if I want to go through and I've got deployments and maybe my deployment pipeline isn't quite refined and it's a little bit messy, or maybe I'm worried about policies coming through where other people can spin up a cluster or spin up node pools and go through and do what needs to be done. This does lean itself into what is Anthos Service Manager, ASM, and not Anthos Service Mesh, but Anthos Config Manager. That's the one where we can go through, and this is an end product of that where I can set a very high level organizational policy which says that all my Kubernetes clusters, when they're deployed, automatically must have gvisor installed. They must have these security concerns and policies defined. This sandbox container is the end user implementation that you don't need Anthos to do this. I do recommend running this where it makes sense inside your environment. So what we've got right now is two basic demos. So it's going back to the idea of what we were talking about before, where we've got two clusters running here. We've got the default one, we've got the more secure one, which is the one I walked you through. So just to go back and double dip on there, I'm not going to say to double click on some of the things which we were talking about in the node pool. So we have got secure boot. Every time a node boots, are we going to check to make sure that the OS is configured and installed in a way which is safe and secure to allow it to connect to our Kubernetes cluster. Integrity monitor. We're going to do periodic checks to make sure that no one's messing with the file system. No one's making changes on the Kubernetes node that it's got corrupted or out of our control to do what needs to be done. We're going to do sandbox with gvisor to make sure that nodes and everything is running isolated inside here, to make sure that the pods aren't accessing and not able to run stuff they're not able to. If we go back up to the top level here inside our good GCP project, shielded GKE nodes. What these basically do is we will only allow GCP nodes built by this cluster as part of this cluster command set to be connected to our Kubernetes cluster. Right now, there was an exploit out there a long time ago where people were like, you could scrape the keys and authentication and just bring in your own node and do what you wanted to do and report and talk and act like you were a bad actor in there. This goes through as well as the security improvement which Kubernetes patched out to make sure that only GCP nodes are enabled to connect to this Kubernetes master to go through and do what you need to do. And this is where we talk about workload identity, where we set up the shared profile scope for the IAM and the Kubernetes cluster. So what I have got here is two horrifically badly coded pods, which highlight two very different narratives as we're going to go through and do it. So the first one, which I got here, is what's running on the default cluster. So my code, you can run this on any Kubernetes cluster anywhere out there, and this is what you're going to be able to go through and do. There's no service accounts, there's no keys baked in, it's just a bunch of very badly written Python running inside here. So I'm scraping a lot of metadata, and the big one which we're concerned about here is the Kubernetes environment. So what this is passing out is all the data the Kubernetes nodes are using to talk to each other to understand. We've got everything from keys inside here to etcd backup locations to rotation to API endpoints. So all these different services and like all the metadata about my Kubernetes cluster is now available to my pod inside here, and I probably don't want that. There's lots of other information we've got inside here, like project name, ID, zone, and stuff like this as well as the compute engine service token and the access token JSON. So you can go through and do this. And any eagle-eyed viewer out there who can copy and paste and write that down fast enough, props to you. You're welcome to take that key and do what you want to do with it in 30 seconds. Here's a bunch of environmental variables, which the pod is able to scrape and see. A lot of these are built in. We can't really do anything about it, but you can see it knows about all the different services. It's got some very specific ones built inside here. Just to demonstrate as well, what I did is I mounted the host node etc, and I also mounted the sys, and I basically did a scrape where I look for anything.ssh or authorized keys past WD, and I read the first 20 characters. So I've got a scope where it's now able to read node values as well as pod values inside there, and this is a website which displays them, which you can spit it out. The bit which scares me the most is this is the default compute engine service account. I'm listing the service accounts and GCS buckets. I can do anything in this GCP project. For a semi-shock value, particularly to myself, I just wanted to list off these service accounts, but I could edit, modify, and delete. And the code for this is very, very simple. If I can do it, anyone can go through and do it, right? By running the same workload on a shielded GKE node, I just go through and I just run the same deployment again with gvisor installed and stuff like this as well. A lot of this information gets scraped out. The Kubernetes environment information automatically gets removed. Yes, I still see all this data, including this secure access token for that, but now my cloud node only lets me write log metrics and logs and performance metrics. I can't do anything else. I'm still getting a lot of these environment variables which are baked into Kubernetes. I can't access the root and I can't mount volumes for my Kubernetes node, even if I try to. It's going to be rejected or it's going to pass it and just ignore it. So I can't access volumes I mount from the root node, and I have no permission to do anything inside my GCP project as well. So the exact same pod deployed, if someone was able to get a bad pod inside there, has a much more limited scope for the kind of damage it can do inside my Kubernetes cluster than what it can't without. And all this particularly comes just down to the gvisor and the configuration inside there. That secure boot, that node integrity check is independent. That's just more of trusting my nodes. All this talks about is gvisor and the sandboxing. It's a very easy checkbox to go through and do and install. And what I want to highlight is I have a deployment. I just want to make sure I'm on the right node. Come on, you can do it. I'm on the wrong cluster, which is why you always check. If I was to go through and do this, ignore the unschedulable pods. That was me playing around with it. So what I'm going to do right now is I'm going to deploy that again, so you can see the exact process which it goes through. So on kubectl apply-f, I know you can't see my screen, so please bear with me for a second. So it is making a new deployment. So if I go over the workloads on the side here, there's a new one here, bad deployment unsecure. So if I click inside here, I have minimum availability, letter of access. It's going to try to provision this pod. It's going to take a few seconds for everything to pod up. Just give this a few seconds. When it pops up, it's going to come back and it's going to basically reject it and saying that you're trying to do stuff inside here which you're not supposed to be able to do. So if I click edit, you can see some of the YAML which I've got going inside here, which is really not supposed to be good. So I've got security context privileged. I'm trying to mount node volumes from the lower location. If I go up, I've got the host PID coming through here. So this is a lot of bad YAML, but it's potential for someone to come through if I don't have a secure tightline. Pipelines or anything like this to come through and do what needs to be done. And it's basically going to say that this pod cannot be deployed in a few seconds for XYZ reasons. So while that's ticking up, as to see Paul pop up, do you have some questions, mate?
Yes, thanks. Just a couple. Since gvisor is a user mode, kind of interceptor of
yes
and such, what's the overhead?
It's very, very lightweight. It's more on the Kubernetes admission, the Kubernetes controllers. For the admission controller aspect of it, the sandboxing part, which is the part of it, is still very lightweight, and it's the daemon set which it runs on the node as well. A lot of the heavy lifting is basically done to stop it getting deployed on my node. and that's where going through. And then it just basically maintains and controls on the end user node. I don't notice it, to be perfectly honest at all. I see an exponential impact when I put Istio on there compared to when I put this on there, like eVisor.
Yeah. There was some question as you've talked about the sandbox containers. Is there a little more detail somewhere that we can look at?
Yes, I know I was a bit light on that, so I will send over some more information. I'll put some links into there, what the sandbox environment looks like on GCP, and also our thought processes around that.
And then there was kind of one orthogonal question, and actually one that I've been asking for a while. KubeDNS, CoreDNS, and CloudDNS. Why so long in getting off of KubeDNS?
It wasn't a huge ask for the longest time. There was priority. It's just out of all the things people were asking us to do. This goes back into what our engineering team works on. Whoever has the loudest and noisiest GitHub issue is where we tend to focus a lot of our time and effort on. So we had some large customers asking for it to get off KubeDNS and be able to support CloudDNS. It was just a lower priority. And at the same time, we were trying to do it in a safe, secure way. So how do we go through and implement this in the right way? Not just immediately throw something up and take the open source version and stuff like this. Well, all that is very much in the company line of like, these are the safe answers to give. Between us, as long as my boss and people on the Kubernetes team don't see it, I don't know. It was so frustrating. Why didn't we do that sooner? I don't know. We should have been doing that for a long time.
Okay. I think that's it for now. Thank you.
No worries at all. Yeah. The gVisor overhead, I wouldn't worry too much about that, to be perfectly honest. It's, yeah. We're going to go ahead. So I'm not sure what I did wrong in my Kubernetes YAML. It's why I never do it live, and we pre-planned all of this, but I thought I would be clever and do it on the fly right now, and it's not working, and that would just teach me a lesson. But yeah, basically, as you know, it's going to stop things being able to deploy and do what they're not supposed to be able to do inside there. It's an option. It's free. Everything we've talked about today, you don't pay for. It's all just baked into Kubernetes as a whole. It's up to you for how you want to deploy and shape your Kubernetes clusters. Some of the features like workload-specific identity and stuff like that are kind of specific to us right now. We are working on how do we tie that into other cloud providers. I think AWS is working on something similar if they don't already have it. I think Azure is in the same boat, Alibaba. I'm hoping the open source implementation maybe has some integration of whatever identity provider makes sense, if it's on-prem AD or whatever solutions make to tie that all together, if that even makes sense. Will be an interesting approach with it. Like, one of the things I'm kind of proud of from Google is a lot of these innovations we try to push forward and make them public. We don't always succeed, but we try to lean into that. Yeah. Don't trust your pods. GCP has a very interesting, Google as a whole has an interesting concept of zero trust. And it runs from everything from our device profile and policies and postures. But when we're starting talking about other factors as well, there's a lot of things which need to be considered. So don't trust your pods. Don't trust your pipeline. Right? Don't trust what's going through there. Verify everything which is going through. So our container registry there's a bunch of really good open source alternatives out there as well, which go through and validate your containers to do what they need to do as well. Private container registries are going to be your best bet as well. Keep that path limited and narrow in your security keys for how you get information out. What's interesting about our container registry, which is merging into Artifact repository, is it can actually deepen your Kubernetes deployment and roll that version back. So if there's a new version of the container and someone's like, I'm just going to pull through this base image, or I'm going to include this library or something like this as well, it goes through the pipeline. If it somehow deploys before the vulnerability scan is complete, Kubernetes will reach in and pull it out. You can also access all these queries from my containers and their vulnerabilities via API as well. So if you have your own third-party dashboard or anything you want to have a look at to go through and see what needs to be done, just go ahead and do it. Also, custom admission controllers, gVisor is a part of it, but only accept containers coming from your repository. Only accept containers which meet certain criteria as you go through the pipeline and do what needs to be done. Your CI/CD pipeline is often one of the weakest points in the Kubernetes journey and story, which we have conversations about, particularly if customers. One of my favorite things is customers just come to us and like, we want Kubernetes. We're like, why? Right? Because we do 1 million production releases a week. Well, like, no, you don't. And even if you did, what would be the value of that? People have idealized versions of it without realizing it's still infrastructure. There's still a lot of support and security which needs to be considered inside this as well. It's another layer of abstract infrastructure. And if we were in person right now, one of my favorite things to do after this would be to sit down and have a pint and talk about, is managed Kubernetes considered infrastructure or platform? And then let's argue out the relative pros and cons between the two. One more thing which this leans into as well is the binary authorization. This once again talks about zero trust. What we can actually do and go through as well is my code, which went through my pipeline, which ended up in my container, signed and secured all the way through the pipeline. So this is, if we get invited back for another session, is more the stuff we want to talk about in that situation there. The overall goal and understanding behind this is like, how do we keep this safe? How do we make sure that when a developer pushes up code, it is legitimately that developer and it is good code, which is running in production, which has gone through your testing cycle, which has gone through your release cycle, which has made it into your pod, which has made it into your Kubernetes cluster. Think about that kind of pipeline process. Think about how you secure that. We have 2FA across the board. If you reach out to me as well, we used to have buckets of YubiKeys at the Google offices. I would just get a handful and I'll give them to people when they come on site as well. Give me a nudge. We've got some of the new Titan keys. I will personally pay out of pocket to give a handful to some people out there who joined the session, stuff like that. We'll go through and do it. And then this is potentially my favorite feature, which we've got coming down the pipeline, which leans into this, is we are integrating etcd directly with key management service. So you can go through and my application sequence can live inside a key management service and etcd would take care of it. So I don't need to push and sync and stuff like that. They're just there. They rotate. They do what they need to do inside there. All the certificates and everything's coming down there. This is in alpha. If you're interested, once again, give us a nudge. None of this has any sales obligation with it as well. We're just here to evangelize Kubernetes and make sure everyone has a good time. But yeah, this is interesting. I'm happy to share some more information about this with the group as well. Hey, Paul, you have some questions?
Yes, here's a question about, at one time there was GKE Premium, and
Yes.
it disappeared to be Anthos. I mean, are they still going to have separate tiers? What's kind of the plan there?
All right. So, all right, Chris Santos, keep me on the straight. Make sure I don't start swearing. So Kubernetes, as it stands right now, we introduced the paid tier, and that came with an SLA. There's a couple of reasons behind the scenes why we did that. One is people were making a tremendous amount of clusters, and there was a tremendous amount of resource overhead, which was just disappearing. So how do we make sure that people are being responsible if they're clusters? We lean into best practices. And also, if we are to offer an SLA, because a lot of businesses were like, I'm running Kubernetes for production, and I need to be able to make sure I can rely on it. Not having an SLA for a production system isn't great. So we had to do an SLA, and to introduce an SLA and expectations, we had to do a price. Anthos is a separate beast. Anthos is Google's vision of, we're never going to be the #1 cloud provider out there. What we're hoping to be is either everyone's second or the best cloud provider out there. And from that means from an open user point of view and perspective. So for me, that takes on the open source approach. So if you come to us, you can build on us. Hopefully our solution will work in multiple clouds. We're not going to steer you and lock you in on what works for us. What we're also asking for, and this is another joke, which I like to say, is people come to GCP for 3 reasons: Kubernetes, ML, and ML and Kubernetes. Right? People come to us because we've been doing this for a long time and we're very comfortable in the space and what we do inside here. So the question becomes like, how do we take GKE and all their benefits and everything that gives us and run that as an Azure, run that on-prem, or help us on our journey to get to that place? So Anthos is designed to be that single pane of glass and that unified layer across multiple clouds to give everyone a base platform. There's another customer I work with is MariaDB. Big shout out to them. Great customer. They've actually just launched a product called SkySQL. It's their managed MariaDB instances running inside a Kubernetes backed, which is actually going to be Anthos native. So you can now have a multi-master replication relational database in MariaDB, which is backed on Anthos. So I could have a master in Azure, a master in GCP, and a master on-prem, and they can all sync and keep and talk with each other. So now my Kubernetes deployment, I can begin to solve and work towards the issue of like, how do I keep my data in sync and almost have a unified platform where I need it? I know there's other tools like CockroachDB and other solutions out there which does it, but this kind of leans into like, how do we meet developers where they are now with minimum effort to go through and do it? So I view Anthos, and what we're trying to accomplish with Anthos is this unified pricing. as it stood right now, a lot of the pricing out the bat and the approach to it was aimed at the very large enterprises, the top tiers, the financial institutions and stuff like that as well. We've changed the model. So we've now started doing like a pay-as-you-go situation. We've even started splintering off a couple of the products and services. So a lot of people, and it was one of my favorite things as well, was multi-cluster ingress. I can have 2 Kubernetes clusters in different locations and 1 ingress, which is shared between them both. That's kind of a huge win for everything from DR situations to splitting the load and stuff like that. That became part of Anthos, and now that's splintering off and not becoming Anthos. So hand on heart, where we are right now, we're still trying to work out what's the best way to do Anthos. If I was in control, I say we should open source it and just get a lot of people on board, because I think it solves a lot of issues. GKE as it stands, it's going to get features. It's got its very own clear roadmap. There's everything from these secrets to a lot of other stuff. And I wish I could share them, but there's a big red banner at the top that says will only to be shared under NDA agreement circumstances, stuff like that. But we've got a lot of cool stuff we've got coming down the pipeline for that. And then Anthos has its own roadmap as well for like what services we're going to work with, like what's that other orchestration platform for virtualization? KVM. We're going to potentially working with KVM, not just VMware. We'll be working with other network providers. We're going to be working with other tools in order to help facilitate running Kubernetes in these different locations. We're working with different partners to bring different services into it. So that is a more commercial aspect to it. Whereas I would say what we're looking at GKE is we're just trying to improve the Kubernetes specific environment and experience. So I wouldn't expect the price to go up over there. I don't control that, but I wouldn't expect that to. But I expect Anthos to still just shake until we kind of settle down on what's going to happen with Anthos and what we're doing with that.
Thank you.
Long-winded answer there. Sorry.
Yeah, no, that's great. Appreciate that. There was also a notion of you were talking about secrets a little bit and securing the encrypting and all that, which sort of this deck thing. Yeah. One of the questions was kind of compare between the notion of application secrets and then secret manager. How do you where's the tie in there? Should there be? Yes.
Exactly. Go ahead, Chris.
I was saying, I think we were just talking about this, weren't we?
We were literally early today. We're having this conversation. We're like, what is the best practices and how are we going to manage this and going forward? We don't know. We don't have a great solution. I mean, one of the things we came up with is because a lot of these secrets, you don't really need them. Is there a way we could come up with almost like a function which can randomly generate the secret, update it in one source, and then make it available in another source? So can I generate a random username and password for my Cloud SQL database and then store that inside KMS and then just have Kubernetes go through and do it? So I don't care, and that kind of leans into the next question, which is like these service accounts with JSON keys. Like if we could just authenticate using those and abstract that out like we're doing here, that's kind of cool. So for example, Cloud SQL is coming down the pipeline with IAM-based login, right? So you don't need to make your own specific one. It's more abstract. So we can make a service account now which has permissions and that can arbitrarily log in. That's just one little part of it. Like the whole secret management, my secret deployment pipeline and stuff like this as well. We're still trying to work out what's the best path. From my understanding, I can't speak for all of Google, just from my understanding in my area where we're going. But that's why I got really excited about this, and I wanted to have this slide up and share this slide. Is like we're leaning into this. We're trying to explore and see what is the best path forward, and understand what makes sense for people to go through and do.
Perfect. One other one, and again, I know that our time is well past, but you can see that there's great interest here and appreciate again your time. As far as the data plane version 2, do you know any time frame for that? Will it only be for new clusters? That's a lot of times with the GKE, it's almost that they're not backward compatible in the sense that you have to bring up a new cluster if you want to get some of these new features, and want to know how that's going to go forward.
I don't know the timeline specific. When I looked at it, it was meant to be Q3 this year. So yeah, that's the last update on the thing. But what I will say is Google does view projects, environments, and Kubernetes clusters as pretty ephemeral. We're hoping that a lot of people have this infrastructure as code. So just roll out a new one, migrate your workload over to that one, then cannibalize the old one. Like we're trying to take our Kubernetes approach. So I wouldn't expect it to be backwards compatible. I would expect it to be a whole new cluster you got to roll out to get that. There might be early access early next year for what that looks like, but I think we're still trying to get the details mapped out on that right now for the control plane too.
So there's been some tools in the past, several quite old. I think ARC was one of them, and they renamed it. I can't remember what the new one is, but when you talk about this old or existing cluster to a new cluster, is Google going to facilitate better the actual migration of your etcd, if you will, to the cluster?
I would say, I think stuff like what's on the screen right now kind of leans towards we're trying to abstract what might be more persistent into more persistent, durable storage locations like KMS and stuff like that as well.
Okay.
So I would expect that to be our solution for how we solve that. The internal conversations, particularly now because we do expect people to have more stateful Kubernetes clusters because we're charging for that, I think this is driving that conversation forward. Once again, this is very much the company line. Personally, hand on heart, I wouldn't expect a whole lot of help to be able to do that. I think we like the idea that infrastructure is immutable. Everything's in the Git repo somewhere, so you just run your Jenkins task again and it redeploys and does what you need to do. But sharing secrets should be in that source of truth, which is KMS. Volume storage or information could be offloaded either to like a GCS bucket or an NFS mount or something like that. Whatever kind of makes sense. And I think that leans into the idea of multi-cluster ingress as well as like how can we start splitting the traffic to make the downtime. I think we would spend too much time trying to backwards engineer and not be able to focus on what we can bring out. I think the priority is looking ahead, I'm afraid. Okay. And I know that doesn't give a great user story and kind of goes against what I was saying earlier where we're trying to be the best. But that is actually a very interesting feedback. And myself, Chris, and Santosh, when we meet with the GKPM, we'll talk about this and see what's coming down.
Originally, I mean, I remember 4 years ago, KubeCon, Federation. Yeah, we're going to be federated, have federated clusters, blah, blah. Kind of a non-starter. And, that was V1. Then V2 is kind of coming out. Is it going to be yet a non-starter, or do you think that we'll truly have, I mean, we just talked about multi-cluster ingresses, great, but there's still a need for a kind of a federated control plane. What's your thought there?
So that's what we view Anthos as. So that's where we've got like the Anthos service mesh and the Anthos config manager and the other, like the Anthos of multi-cluster index, is that aggregated control plane above. So I can set my unified security policies. I can tap that in as my deployment gateways and stuff like this as well. So we've pivoted regular Kubernetes and federation into that Anthos. I would say my big hope would be if I didn't want to pay for Anthos, which personally I don't want to, is to see what we get out in the open source control plane. But yeah, if we look at the documentation internally about how Anthos is structured, it is that federated aggregated control plane above the other Kubernetes clusters, and that's our ingress and gateway for all the configuration and controls and cluster spec management, if that makes sense.
Okay. I know that we've had a lot of questions. How many more slides do you have?
That's it. That's literally it. The next one is literally thank you and ask us some questions. Well, and I know I'm speaking a lot, so Chris Santos, please shut me up. I can talk back legs off a donkey. So,
Well, I don't think we have any more, or if they do, I guess there's one here on how do ephemeral clusters work with config connector?
Yeah. They register themselves against that central control plane. So the config manager, you're going to have that Anthos thing. And so when ephemeral cluster dies, it comes back up. It's going to register itself just like a node does against the Kubernetes master. The Kubernetes master is going to register against a higher one. And then it's just going to basically be told, hey, here's all the configs you need to be. Here's my default security posture. You're going to do what I say. And it tells it what to do.
Perfect. All right. One last call out for any other questions. I think it's been wonderful. You said you had some contact information if there were other questions. Is that correct?
That is absolutely correct. I'm going to put my email inside here. I am one person, so we're federated out. I don't want to volunteer Chris's or Santos's email right now.
Absolutely.
Okay. And we also had the repo, it looked like, for this meetup. So,
yeah, specifically for this meetup, we've got a couple of sample apps inside there. The idea is we're going to grow this over time. So if we get some more talks or get some interesting stuff or any feedback,
do you have that as well?
We'll put that out. It's not 100% right now, and we want to clean it up a little bit right now because some of the stuff doesn't do what it's supposed to do. Some of it does stuff it's not supposed to. So we'll get that going. And thank you, John, Chris.
I think this has been a marvelous evening. I appreciate all of your time. Thank you, Rick, Chris, Santos. If you're willing, we'd love to have you back sometime. And just as you can tell, we have a lot of interest, and we appreciate the insights that you get.
I'm very happy to help. Very, very happy to help. And if we want to go deeper and stuff like this as well, I just try to dive between occasionally. If there's anything else we're interested in from a Kubernetes or stuff like that, if we all get drunk and it's not recorded, maybe we could share the roadmap at some point as well. Something like that. We'll go from there. But thank you very much for having us.
All right. Thank you, and be safe, everyone. Appreciate you.
Take care.
Thank you.
Bye-bye.
Bye. Bye.